just to make you aware. You worked on your homework assignment, probably you've used the GitHub repository. Just before we dig into the lecture, are there any problems, challenges, questions you might have? All good? No problems, no obstacles? Yeah, sounds good.
I did catch, I did want to note, I heard some discussion about problems with that were essentially possibly being attributed to Windows, and I've been running cadCAD on Windows and on Linux, so if there's anything that comes up, I can help with. I can't help with Mac though.
Okay, cool, but good to know. Yeah, and Hendrik dropped the question to the chat. I think that's also for everyone relevant. Arrange a walkthrough through the code. Maybe Hendrik, do you want to repeat?
Yeah, no, I managed to install it and get my Windows Python Jupyter thing working. But then I was maybe, what's the right word? Overwhelmed. So although I can follow sort of the layout and it follows your structure, etc., it would be pretty nice to get sort of, okay, how does it actually work and what's the thought process and why did we actually end up with this setup? So more sort of like the thinking on the different functions and policies and parameter selections and etc.
And I think Chris added some comments there. Chris, are you in the call?
Yes, definitely. So what we are going to present today, I think, correct me if I'm wrong, Balin, but I think that you will partially show excerpts of the code today. So I hope that this will help the participants to understand the model a little bit better, in addition to what Jamshid showed last time. So I think that he showed the partial state update block and also some of the mechanism hubs for you to understand where the proper functions are called at which place. And starting from, I believe, next session, we have a tutorial for you prepared that you can download, not really download, but you can access online and then walk it through and apply particular changes to the model to see where things have to be changed such that the model behaves differently. And I would ask you to wait until we've covered the next sessions and discussed everything through that is relevant to the model. And in case there are any additional questions, we are happy to dedicate some time on a hack and share session to spend on the discussions how the model works.
Okay.
Yeah, I can just add a little bit of that, like we're starting to delve into what is in the model. And last week was still kind of on the as a GDS. This week we're going to be a little more specific as we go through the math specification and looking at what's in the model in terms of the actual functionality that's there. And then next week is really going to how cadCAD works, almost in terms of like, think of it more as turning on the engine, like once we've built everything, and how does that actually work? And it still ties in all directly with how a GDS is set up, how the specification is set up, and really like turning on the cadCAD engine to make that dynamic system spin.
Mm-hmm.
So that will be the focus of next week's lecture is that the dynamics and how it works.
Great. Hi, Pranav.
Hey.
Hey, hello. So any other questions so far on things you did last week, on things you've tried out, things you're struggling with?
Yeah, I've got a point. I mean, I'm in the same boat as Hendrik.
Mm-hmm.
I'm struggling with Windows. So maybe if there's some sort of a session to handhold us through, would be great. I mean, if it's not asking too much.
You mean particularly for Windows?
No, I've also got it installed and running, but then I'm stuck. I mean, running in the sense that I'm not able to actually see the graph.
Okay.
So I've got it installed, but I'm not able to really run it.
Okay. Yeah, maybe then we should check it for the hack and share. I mean, this is a great topic to have it for the hack and share sessions to also support each other. So I would appreciate if you guys, anyone was able to run it, got the graphs, is willing to have a, let's say, co-programming session together with Joe's, and so that we can find out and sort out any challenges here.
It's Windows. I mean, I think, Hendrik, are you in the same situation? You're muted.
Well, I had I was taking the cadCAD training, and then you install the Jupyter, the Anaconda, and the Jupyter Notebook, and it fails to launch the pip command from Notebook. There's apparently a known bug between Windows and Jupyter/Python on that. But then instead of running the pip command, you basically import the sysac and put the command line in where you actually take the notebooks and you just throw that in instead of running a pip, and then everything worked fine. So that was my challenge solved. But I don't know if I spoke with one of my son's friends who said, "Oh, you just got to partition your hard disk and establish a Linux hard disk," and I was like, "Well, okay, maybe tomorrow." So if it's that sort of simple command thing, which frustrated me a lot because I haven't seen it before, then fine. I'll put it in the chat in a sec. In the chat in a sec. If it's more than that, I'm for sure not a Windows/Python/ whatever expert. And then there's all sorts of things that can apparently go wrong. And there's a Stack Overflow library that is 10,000 pages probably on weird Windows stuff. So I invested in a Mac instead. But that's not solving your problem, Jose. So I don't know what it is.
Also run Linux in WSL, Windows Subsystem for Linux. So that's integration. That's like a Linux that's really well integrated with Linux. And all your C, D, and E and F drives are already visible under Linux. And it's, they are basically trying to make it like the Mac, where it's very user-friendly, but then you have a command line that works just like a Mac's command line terminal. And that's how Microsoft is pushing this Windows subsystem for Linux to appeal to the developers.
That sounds good. So if you can drop any links to that in the chat as well. And also, guys, really reach out to the chat in case you meet such problems. Don't wait for, okay, the next lecture, the next hack and share session. Just reach out. We are really happy to connect you with people who might be able to help. And of course, the purpose of this whole research group is to help each other with skills and recommendations. So yeah, just this is an invitation. In case of any problems, just reach out in the Discord.
Yeah, so no, I'll say again that it's not it shouldn't be a Windows problem with cadCAD, or it may be how you've installed Python, whether you've done a local install or whether you say you're using an Anaconda installation. That may be the issue, that you may be trying to pip install a library and it's going into a place that you think it's going to versus not, like if it's in your or if it's in your condo environment versus say locally, that may be what's happening there, but it is typical with Python that we import libraries and we put those in our notebooks, but it is that you do have to pip install those libraries first, and they are in that requirements that text, and yeah, so I can offer some help on Windows, and then also when I said I run on Linux, I actually run with the WSL, which on a different machine than I do Windows on this one, and then I actually do a WSL on a different machine, which also it is very nice as well. That is a rapidly improving product too. By the way, the WSL they're on WSL 2, kind of came out, I think, in April.
Yeah. Okay, thanks for these notes, Balin. And again, I just want to encourage you. This is always a steep learning curve and also a barrier. So if you are not using Python on a daily basis and then get up to speed, have everything ready, this is a typical challenge. Don't give up. Sometimes it's very frustrating in the first place, but once you have it running, you'll enjoy it, and then you can finally concentrate on what we actually want to do. But it's just important, keep on pushing so that you get your environment ready and cadCAD ready, because otherwise you're just stuck in these technical issues. And again, we are happy to support you. Okay, that said, let's start with the lecture. Balin, oh, I should enable your screen share now. All right, let's go. I think you're muted. Now.
All right, and where did controls go? There we go. Sorry. Oh, there. Okay. Okay. Let's see. I trust everyone can see my screen.
Yes.
All right. Okay. So yeah, welcome everyone to the focus on the mathematical specification session. Some early points are that everything is tied together, that we are kind of iterating through, again, this design process, and where we kind of started, or where you saw last week about the GDS, really what we're going to be doing here, saying, okay, what is the system that is part of this generalized dynamic system? We have to specify what this system is, and that's really like the focus of today. But then also we're going to look at what the Hydra system is, as well as the implementation of that in the cadCAD model. So really, GDS is this abstract thing about how a system may be generalized and be dynamic. Here we're saying, okay, what is the system? How would you create the system? Here's the Hydra system. Here's how that would be coded in a cadCAD model. Okay, so essentially we'll roughly go through those things. So we'll talk about a little bit about the specification and how that comes about, and some thoughts also, especially around the design process. And then we'll go into the different pieces of the math spec itself and the specific Hydra. So yeah, so just want to talk about a little bit about this kind of map about a design process and how we might think of going. We have different ways that we can always think about iteration. So like whether we're talking about, kind of like the roadmap that I presented a few weeks ago, and how there's like iteration over phases, or whether we just think about the different ways that we can kind of go through this process and what that might look like. So really just kind of some more visualizations about what we might see, where you might kind of, depending, and really, there isn't necessarily a starting place and there isn't necessarily an ending place. Really, it could depend on what what you are looking to do. Like, so whether you're just looking to design something from scratch, you might start with, an ask. You might have a question, like as, how they might teach, some, used to teach like some engineering courses where the focus was to invent something, right? So you start with like kind of like a question, right? Like, I hate it. The thing is, like, you ask a question or fill in a sentence that says, I hate it when blank, right? So that might be something to kind of give you an idea for an invention. So that might be starting here at this point. Other designs, you may be actually observing, say, something that's already happening, say, like, in Ethereum or something that you're noticing something, and you're realizing that there could be a better way, or you're observing something that is against, say, like, the ethos of Ethereum or some environment that you're working on, etc. So, like, really any one of these places could be a starting point, but the idea is being that you may have a question, that really a little bit goes to like those requirements that we've been talking about, like the map goes to kind of that GDS and the system, making those system maps, right? And then model. So we have cadCAD in there, but it's not the only game in town. There's plenty of different ways that you can model things. And then in the really kind of the last of this series of lectures, where we would really kind of like go through some of the both presenting results and really kind of making some observations. We won't really be going through kind of necessarily the debate part, because that would be where you would say, like, where you would bring it to everyone and say, okay, like, is this doing what we intend to do? Have we thought about this? What about that? Those sorts of questions. But either way, like, this is roughly one way to think through the design process about, what we've been doing here, and what you'll be doing in the second part of the series, as well as, like how a lot of these systems have been developed, at least if they've been, we might say, like, engineered properly. So iteration, we can think of it lots of different ways. And here we're kind of in that kind of smaller loop that we've been talking about, where we've been talking about the map to model and that loop. And that's really kind of where we are right now, with not only like essentially with this project, but also you stay in that loop a little bit until you're sure that you have something that is meeting those for the first set of requirements before we go into, say, much more advanced, I wouldn't say advanced, but like downstream effects, say, of other cases of how that might be implemented in a real system. Those sorts of things may come later. And so, like, you do as much as you can within this loop before, say, moving on necessarily to all the other downstream effects, because the focus here is actually designing that system. So we kind of go through that ask model phase, and that's roughly where we are here. And so again, with those three phases, what we've really set out here is to really kind of have an idea, as well as an implementation of each of those ideas, and something that we can kind of say, okay, like, well, so we can identify, say, where those assumptions may be correct, where they may be failing, or where there may be a failing, say, within the mathematics of what you formulated, or like I said, or maybe it was an assumption about your boundary or your system itself. So by having like each one of these things, that's how we can kind of go through those three sets of the map model ask loop. And yeah, just kind of like another way to see this would be that, again, we've have this idea about this generalized dynamic system. We earlier started about system boundaries and its interfaces, and today we'll be talking more about like what is in that system itself through a specification. But you know, I'm going to say it again in a couple more slides about that this is still iterative, that there, you know, we may have something, we may have decided something here that we realize that is making this maybe like not have a solution, some algorithm in the specification that, like, say, doesn't have a closed solution, and they may need to revisit the system boundary, for example. Yeah, so really, you know, these kind of three ideas about understanding each one of those, both individually, but then also how they interact with each other and how they're tied together. Okay, so we'll focus on the math specification, but like I said, well, actually, do you want me to? I'll stop there for any questions about, you know, where we are in the lay of the land before we go into this third piece of that land. Any questions? Anything burning in the chat? I should.
No, it doesn't look like that. But anyone, feel free to drop your questions to the chat too, of course.
Yeah. And I'll let you, Joe, if you don't mind, you can certainly interrupt if there's something in the chat that.
I'll let you know.
Perfect. Okay. All right, so we will delve into the mathematical specification. Okay, so one more iterative loop. So picture to think about. So I'll talk about this for a few minutes here, because this was my background in naval architecture, in designing basically anything that floats. And you would actually, so we would call this, this is called the naval architecture design spiral, where you would actually go around and around and around. But they had fairly distinct phases. And what you would do is you would start with, you know, really like as someone that was designing these systems, you know, someone that comes to you and they have a set of requirements. I want to move this much stuff from point A to point B. It may be a requirement that I needed to get from point A to B in this much time, or it may be a requirement that I needed to get from point A to point B as cheaply as possible. Those are often two conflicting requirements. So, you know, we often start there and we go through the concept design phase. So really like kind of a first pass around all the necessary major parts in designing a ship. So getting, you know, really what we're talking about here is getting rough ideas about how long, how wide, and how deep it might be. A rough idea about how large of an engine and what your fuel consumption might be. And getting a rough idea about say the cost of what that system might entail. And so, you know, this concept design phase, and so we'll kind of match this to the concept math spec I'll be going through here. We'll kind of, again, keep in mind like that, you know, we really consider it that first pass. Getting a rough idea, again, is that rough idea of everything that would entail that system. Now this, like what really works, really fits with how we've designed these systems at BlockScience and how we've seen this go in terms of like an overall design project. We see that the next step here, like the gray spirals, are the preliminary design phase. And so what you're working on here, what we're creating in an analogous for us would be the preliminary math spec. And so we'll go through like what those differences are But some important points here in real life, that you are going through the same things in designing a ship, where you're going back through all the same ideas, but you're really making you're narrowing down very specific ideas or design decisions, I should say. And then the other important point in this phase is you are doing a lot of modeling and testing, whether you're doing computational testing or whether you're actually building a model of a ship model and running it in a design in a flow tank, or in a tow tank, I should say, or in a flow channel. Those things happen in this phase. So this phase can, in naval architecture, can take some time if you're needing to test something new. Often we're testing, say, the resistance or stability to get better predictions about what power we might need, or how large of a wave, say, the ship would handle, those sorts of ideas. But that phase, often leads to design iterations. And so, one of the key things here between the concept and the preliminary is that, we can roughly start, say, like when we're done with the concept mass spec, that we can roughly say, okay, like here is a good idea of the system. And then as we go into this preliminary design phase, what we will see happen is that we're often specifying the set of algorithms that are making up this system. And in real life, that doesn't always mean that the first set of algorithms that you come up with are the best. The idea is that this is the first set that fulfills the requirements. So we're always trying to say, okay, are we still we're still doing a little bit of that requirements phase, where we're saying, hey, like, does this set of algorithms still satisfy the requirements that I've laid out? Sometimes they might say, oh, wait a second, we were wrong in those requirements, we need to adjust that. That absolutely happens. Ideally it doesn't, but that happens. And the other thing is, like, there are some real constraints about when something needs to deploy, and what actions can be taken later to, say, improve. So again, here you might say, okay, well, here's a mechanism that works, it satisfies all the requirements, we're going to keep building and iterating on it, but we can push this through to be built, essentially. And so that can go, that can continue.
Okay, we have already 2 questions in. First,
Sure.
One in the chat, and Paulina is raising her hand. Paulina, you can next. I first take Dr. Lau's question from the chat. What about complex adaptive systems versus engineering when don't know requirements? So like waterfall versus agile development.
Oh, okay. Yeah, so that may mean that in that case, that if you're saying, well, if we don't have the requirements laid out, but we still have, say, a known system, or known parts of a system, right, that you can still model and design, and then have, say, unknown pieces, so some of the ideas that come into play there that we've talked about a lot is system identification, and so that's a concept where essentially you know the output of a system, where you don't actually know the mechanism, or like it's often associated with physics of you don't know the actual, you may not know the physics of that system yet, you just know the input and the output, and you can derive based on the inputs and outputs, essentially deriving what the underlying physics are. So yeah, so that is, it's an interesting question that, yeah, if you're not coming in from the point of view of here's a client, here's someone that has needs, we're going to fulfill those needs, versus, hey, I'm just going to build this better system. But then you may still need to make those, you may have already in your head what defines that better system, right? And you would still have some specifications about that. Does that answer it?
I would like to add something here, because maybe in this respect, it's interesting to take a look at Ocean and Ocean Spice, Token Spice. This is an alternative simulation framework, but this is not the relevant thing at this point. Here it's interesting to just take a look at how Trent simulated his systems based on the capabilities of the system implementation in every iteration. So they had an Ocean system, Ocean protocol version V1, V2, now V3, and accordingly, well, the system became more sophisticated step by step, and accordingly also the system design, the requirements, and the actual model for running simulations and verifying assumptions, for example, on the flow of Ocean and some fees that are going to the DAO. And there, the first version of the simulation was, for example, we had just one agent representing staking and speculation. And in the latest update, now we separate, and this is also technically separated now, and we reflect that in a simulation. And so I think this is also an iterative process, most likely in parallel to what the roadmap looks like for a crypto project, for example, where they also don't start with the full complexity, or you just adapt to additional opportunities, new roles, and so on. Okay, my 5 cents on that. Paulina, you have a question.
Yeah, my question kind of ties into with the discussion we just had. I was wondering, so when we come to an iteration or reiteration of a model, do we, like, what are the metrics that we decide upon how we reiterate? And are they more geared towards looking at the effectiveness of the mechanism in reaching the predefined outcomes? Are they more geared towards actually looking at the validity of the model itself, or is it kind of both?
Very good question. So, so the first part is that the first part of that question about the model, we're gonna talk today also about that in the specification. We would have metrics or KPIs to analyze the first iteration and say, okay, are we meeting those KPIs? And so we do try to set those forth even at this stage about whether they're and we'll certainly talk more about like whether those are hard constraints that are set forth within the model and within the specification, or whether they're essentially design goals, and that's where they may not actually be in the model itself, but in the analysis of, okay, here's how it ran, did we meet? And so that's where we essentially do the analysis about the data, the simulation data that comes out. So yeah, so that's the first part of the question. Oh, and then yeah, so very differently, and I think we've talked about this, but certainly it's a good thing to always talk about, that we talk about verification and validation quite a bit. And yeah, so absolutely, what we always do is we do verification, is where we're saying, okay, here's the mass specification, here it is in the model, and we do very simple tests to make sure that the expected input and output from the math, so analytically matches the numerical experiment in cadCAD, and that also may mean doing, numerical calculations, whether, Wolfram Alpha or by hand and double checking. But yeah, so absolutely we do the verification phase. It's, I shouldn't say a phase, but it's a very important step for each action, say, and make sure that is verified and resolved correctly before we move on to then say validation, where we're doing, say, a larger simulation and looking at say output of the system and validate that the results meet, say, the requirements.
And just a quick follow-up question on that. So would you say that once you have specified the cadCAD model, do you have some sort of like baseline scenario that you can run in like checking whether for example, macroeconomic dynamics actually match maybe real world behavior?
I wouldn't say we wouldn't go right to real world behavior. That's more in validation, where we are trying to then, like, that's where that gets more involved, where we're saying, okay, like, here are all the things that we start with. Okay, here's the thing that can happen. Did it happen correctly as we've defined it and implement it, right? Like, so we have to make sure that those things first agree, and then when we get into real world behavior, okay, well, here's these different combinations of things that can happen, and at different degrees of, say, both complexity, but say like of magnitude and frequency, let's say, and then you're essentially doing different amounts of validation testing really about that, like, to get to say simulating real world behavior. That you can build quite a different set of layers, as almost as Angela was pointing out before, with the different versions in token space. Say, okay, like, here's a simulated agent. Oh, here's a simulated agent for each action. Oh, here's a class of agent that then has 10 different that has a choice over distribution over preferences, and let's deploy all of those. So like, those are all kind of building up the layers that you may be testing.
So almost like in your little spiral there, like different lines, like verification first, then validation later, and then it goes into the next iteration.
Mm-hmm.
All right, thank you.
Yeah.
Hendrik, you have also a question.
Yeah, maybe it was more like a comment. Can you hear me? No, it's just my video. Okay. No, I actually 15 years ago, when Denmark wanted to buy a new combat fighter weapon system, and we have these EU procurement rules, you have to treat everybody equally. So this was a question: how do you treat Lockheed Martin versus Boeing versus Saab versus the French, whatever they were? And that was actually sort of the mathematical specification of a system that wasn't ready yet. So and then it was said, well, actually, this is very uncertain. So how do we treat people equally under uncertainty? And the way we went about that was, at least from the cost perspective, I mean, there was lots of stupid things that were assumptions were wrong. So, for example, they said, well, our military strategy is going to be the same for the next 30 years. And then I started looking and said, well, that's interesting, because we changed it 4 times the last 30 years. What makes you believe that we're going to fly around throwing bombs over Afghanistan and Iraq for the next 30 years? Maybe Russia enters Ukraine and will have civil unrest for the financial crisis, which becomes economic problems, which becomes a different threat pattern, that sort of stuff. Well, that's a sort of, no, don't worry about that, because we just need to compare the systems. But then we actually took, so basically in Matthew's model here, the cost estimate, I guess, was what this is a cost model. So it's a life cycle cost model of a weapon system, which is the procurement, the maintenance, and the upgrade, and the logistics, and all that stuff. And we started saying, okay, what drives the uncertainty around that? So it became very adaptive along the way. And then we basically set some parameters which were very crude, and then ended up actually finding in the first run that the distribution of possible outcomes that was sort of like $70 billion plus minus $100 billion. So, I mean, that's pretty damn hard to make decisions in that sort of range. So we started fine tuning, and over, like, I think maybe 10 iterations, we actually got to something meaningful. which also held up with the national auditors and the Ministry of Finance and Treasury and God knows everybody. But it was a way to go about specifics. If you don't know, maybe it's also to Dr. Lau's comment there. If you don't know, well, start with some crude parameters and then simulate, and then you run, you look at the expected shortfall and see what drives actually the outcome variation, and then you get more clever and focused from a sort of a risk-based maybe thing. I don't know if that's helpful, but at least it reminded me of how to actually model cost under something where you don't know what you need.
Yeah, so I don't know if you've noticed, but 2 lectures from now is entitled Parameter Selection Under Uncertainty. And it's actually an analysis, still essentially, it's almost analysis of the output of our simulation and how we can essentially use our simulation to choose parameters under that uncertainty. So yeah, so that's absolutely an important point. That'll be the 6th lecture really devoted to that workflow. But yeah, like that's.
But you know, there's actually maybe, but when we get to that, because there's human bias here, and because I started from bottom up and then ended up the most cost-effective weapon system was actually not the one that the military wanted, because they all wanted to fly with all their buddies who had the same fighter jet elsewhere. But even with just, and there's of course synergies and what have you in the logistics, but even with that, there was another option that was actually from an economic perspective better. So then we started, and there was all sorts of workshops saying, well, actually, I think, no, we shouldn't treat that variable like that. So I kept sort of a log of all the models, and you could say, okay, from model 1, we actually selected, say, Saab, and in model 10, it was actually Lockheed, because everybody wants to fly F-35 or whatever. And actually, it was actually suddenly became much cheaper, even though it was actually much more expensive. So I'm just saying there's a lot of bias that goes into that phase with modeling uncertainty, and you can basically fool anyone. So if it's too uncertain, yeah, it just becomes, what is it, sit in, sit out. Yeah. Anyway, look forward to that session.
Anything else? So yeah, yeah, I'll just say here, like these kind of inner points here in naval architecture land, this might be where you're actually generating the blueprints and giving this to the shipyard, and then often the shipyard would have their own draftsman like to actually be able to build it. So like for our analogy, what BlockScience might do, and I've done in several cases, is essentially take our finished preliminary mass spec and map it over to say to a blockchain system, and like specifically I've done it with Cosmos SDK, because they actually have a system that's built modularly, which is very nice. I much prefer that. And so we're really that's another advantage of going from with the mass spec, is that it does kind of map pretty nicely to some actual deployed blockchains. And so like really that's where like say like this actually gets much simpler to do this phase here of saying, okay, like here, like essentially generate the blueprints from a mass spec. Like we won't be going into that here, but just like it's an important point that like we could, we're still actually trying to build something like the necessary for the build system. So it does allow us to do that. Okay, so here's we're going to go into all of this, essentially all the different pieces that make up our mass spec. So this is the entire overview of what is in here, but we'll go through each one individually and talk about those. So like essentially we'll have some reasoning about the state, and that's usually some combination of the global state and the local state, and we'll talk about those individually, and we'll kind of do a mechanism mapping and the action space, and as well as the metrics. And so then what I want to point out here is that like where we sometimes where we try to draw the line, I should say, about the concept mass spec would be to really have a good identification of all the states and the metrics and the mechanism mapping and the action space before we delve into actually designing a set of algorithms in the mechanism specification. And so that, like, that's where we're in that preliminary, that's where we consider ourselves in that preliminary mass spec. We're able to actually go and start defining what those algorithms are and go and test those. So that's kind of like where we draw the line, but we're going to go through like all these time allowing. So really kind of some ideas here, just like in general, that, you know, like I don't want to, like, there's always that tendency to feel like, okay, like, well, you're just going to like fill this in or go like start at the beginning and go straight down. And, you know, again, that the whole idea that like really you're kind of like thinking about all these things. So you kind of start with, okay, like what if we didn't have anything to start with? Well, what do we know? Well, we might look at that system map that we drew, right? And we might say, okay, here's what I know is in the system, and maybe I can define a few of the variables that are in that system, and define what's out of the system, and be able to say that that's exogenous. We'll talk about that. And what do I need the system to do? Or we might say, look at a user and the different types of users and say, okay, what are the actions that I just want them to do? And really kind of like, so, you know, again, you're kind of jumping around a little bit to say, okay, what are the things that I need, and kind of going around to make sure that you've kind of gotten everything correctly. So, you know, at this phase, at that first kind of pass through, you know, really just thinking about those system ideas and the domains and the dimensionality, say, of your state. Like, you know, okay, is this, you know, just a number, or is this, you know, some matrix, or like the set of all wallet addresses, etc. Those sorts of things to keep in mind. And again, like always with respecting like what the requirements that you set forth, but really, like, again, you're using those two previous pieces, the requirements that you have and some system map to kind of build this, and also, you know, still ask questions about whether what you did is correct about the requirements, or what you did about the system map is correct, right? If you're really butting up against something that you feel is incorrect, like this is the time when you start thinking about those things, and you may make changes. Okay, so kind of trying to tie this back to what you saw last week with the GDS. The first place that we'll dig into is like that global state, like which we you know, just use as X, the state of the system, and really like and sometimes we even might just say like it's everything, right? Without any further clarifications or subsets, but we're going to try to make those distinctions about those any subsets of the global state where possible. Helps for both designing, helps for also building, to make those distinctions. So you know, like, but there isn't, it really depends on the application, right? Like whether these are available to you or not. So we'll talk about these, each one of these in a little more detail about whether, like, if it's a blockchain system and whether you have certain tokens, or whether you're able to say like have sets of tokens or different classifications of those tokens that may be that's often where we might be living with our global state. We might have stateful parameters, things that are, you know, quite frequently those may be values that are being chosen. Nothing makes those be, say, constant, or you know, they can still be updated just as easily, say, as a state. But so like some of these distinctions can be a little bit fuzzy, depends on really it can also often depend on where you are in terms of the chosen platform that you're building on. And we'll talk more about, let's say, like metrics, say stateful metrics that are actually part of the state themselves, versus say like, you know, we could either just say a metric or a KPI, something that you might just say analyze, or it might come out of what the actual what the state of the system is, and something that say like a user metric or like a performance metric that isn't say critical to the operation, like to the functionality of the system, but maybe, you know, of high value to say the operation to users using the system. So again, like that distinction, you know, sometimes can get blurred as well, but really depends on some of those design decisions. And we'll talk about like what the local state might entail, both again from the specification and also like what is in the model, and also identify if we have any exogenous variables that are extrinsic but important to both the model and the specification. Okay, so if we are able to do a breakdown of say specific token states, you know, all we're say the first pass might be trying to capture some ideas about what those tokens are, the nature of them, and you know, any both the initial quantity and say like how they may be changed. You wouldn't go further into say like this dynamic characteristic of how they may be changed directly like that. That is probably going to be in your set of algorithms, but like some idea about some expectations here. But often, I mean, there, yeah. So we would have a symbol, and we might also have say like, like we would have the domain of that as well. So then we have these stateful parameters, and so again, like these are typically values that are updated, or that can be updated. They don't have to be, and they are essentially, you know, values that essentially almost are part of the functionality, say, of the set of algorithms that affect the token state. So so they're often they're, you know, inputs into those functions. Like I said, they don't have to be constant. They could just have a different process or a different, say, like whether it's something that comes in from, say, from a governance, something from outside that, you know, an external process that is necessitating, say, a change, say, to like a fee or an inflation rate. Those sorts of things are all what would be certainly stateful parameters. They're, you know, as values that are absolutely necessary to make the system work, and you know, they are, you know, certainly separate, you know, from like, okay, well, like what is the state of the system versus, you know, of like, okay, how many tokens are there versus, okay, what is the fee, like that sort of thing. That's why we have that distinction. But it, you know, it also lends to an available control surface that we can use as well, right? Like, so like a change in, say, a parameter doesn't have to be driven by, say, like whether a centralized decision or a decentralized decision. It could come from actually a process that's from the dynamics of the system itself. So next we have stateful metrics, and some ideas here, again, like that the difference between, say, this and the KPI, you know, I think importantly, it's almost easier to say the other one first, is that, you know, like if we're talking about a KPI of, say, like, you know, a design goal or like a desired achieved, say, you know, return for investors, et cetera, then, you know, those are things that could necessarily be done as analysis about what was happening with the system, versus something that actually, versus a metric that actually needed to be part of the system itself. And so the couple things here to discuss are that, in some cases, like in a cadCAD model, there may not be that difference, but you can actually, but there may not be, but or there may not be. And I should say what I mean by that is that, like, we can sometimes model metrics inside our cadCAD models, or we might do, and that would certainly be a stateful metric, but it doesn't have to be. We may do it for simplicity's sake, or sometimes having that metric as available, say, to an agent, which isn't necessarily something that is actually part of the system itself. And a KPI might be like, if we see something that we're just analyzing after, then we're very confident in that fact, then that is not a stateful metric. It's not part of the state of the system. So like that's kind of like how we try to determine that distinction. Yeah, question.
Yeah, we have already 3 questions. Paulina, I again start with the chat first. Hendrik, determine the critical variables.
Yeah, this was, I mean, at this stage, how do you actually determine what variables or parameters to select? Because do you have a process like it's a brainstorm, or it's I don't know, there must be some odd way of getting to the point quickly, or do you just throw what you have at it, or what sort of process do you use in your engineering process?
Yeah, so I would go back to what I said before about when we're doing the mass spec, about that we're not just going right down the line, right? That we are actually going around. So we might be saying, okay, here's our token state, and here's the mechanisms that we need. Oh, I know in order to make this mechanism work, I'm also going to need, a parameter, that helps me do that, right? Or it might come from a requirement that says, hey, this is a system that has governance on top of it, and they are going to choose, this value that comes in.
Okay, so basically you're throwing as much at it as possible to be sort of holistic, and then the simulation will later determine what actually matters, or is it different?
I don't think I would say that. I think I would say more, I do this more from, say, the functional view, that if I have a known set of actions and mechanisms that I need to make happen, that given a set of inputs, say, and my first set of inputs are the token states, and I know what my output needs to be, and is there anything, what else do I need, right? In order to go from input to output, what else do I need in that function? And so that really comes from the development of that function itself, let's say. And, oh, well, I realize I'm going to use, like anything, like, so if I use like a log, say, oh, well, I'm going to need some rate, some way to control the rate, right? Okay, well, that's going to be a parameter, but it really kind of depends, again, like through that development.
Okay, thank you.
Yeah. Go on.
And there's a second question in the chat, Dr. Lau. I'll read it out. What about variables highly subjective? For example, preferences for crowding M/2 of co-working, e.g. US chair size versus Indian cramming. Not sure what that means. A variable more range, not a point value. How to deal with this? Variables highly subjective.
Yes. So in terms of that, it sounds to me like what you're talking about then are, say, decisions that may be, I should say, it's information that would be used in decisions, say, from an actor or a set or agents. And so that's where going back to an earlier thing where I was saying that we may have some metrics that are in our cadCAD model that we don't necessarily consider stateful metrics, but we may be using them to generate user preferences or user decisions. And so that's where we would say, okay, well, it's not part of the system, but we know that this is how people are going to make their decisions. And we'll see kind of those pictures, like when we go to or see the picture again about the GDS, about the G to U, where we're saying, okay, here's how they make their decisions. And that input necessarily isn't actually part of the state itself, but it is, essentially you can compute it over the state with your own sets of preferences. Does that answer that question?
Dr. Lau, let us know if there's still an open question or if we shall specify again. Paulina.
Yes, I was wondering about the last point that you made in terms of the stateful metrics versus KPI. Could you give an example for when a KPI is not a stateful metric?
Sure. Yeah. So like even in this case here, we're gonna well, yeah, I'll say. I'm gonna have some cases for the Hydra that we'll see, but say for instance, let's take, how familiar are you with Uniswap, let's say. So we may have that there are, so built into Uniswap, we have our token states, the stateful parameter is the fee, right? And so they don't have, as far as I know, like if you go to Uniswap, you see what the slippage is, right? But they don't have that built in, like that's not necessarily stateful, right? Like that you're seeing that, and that's how you're essentially how you're making that decision, right? So that's certainly I should say that the KPI would be what you actually get out, right? And that certainly affects your decision about whether you can come back and use it again. But certainly within this, but you would certainly have known, and you would build this into the cadCAD model, that you would have the metric of slippage as a stateful metric because it's intrinsic to the operation, right? That you're going to have, is going to be able to be known and computed at the time of the state. Whether you actually get that or not, right, is a different story. But it's still part of the operation.
So almost like interim metrics that then define some like larger KPIs, but then all KPIs are kind of also metrics from the system. So yeah, there's never a KPI that isn't like involved in the model already, right? Otherwise we wouldn't be able to measure it.
Right. So yeah, so this is what I was saying, like it is a little fuzzy, but we can make the clear distinction that say like a KPI that doesn't affect the actual operation of the system would be, say, something that we can just run the simulation and then say like do the metric analysis after the simulation. That gives us a pretty clear picture as to like, okay, this is just the KPI. This is just something that people are gonna like care about after. Or like, I mean, even during, but it's still, like that the system can run and not fail. Yeah.
So all metrics metrics plus analysis leads to KPIs at the end.
Mm-hmm.
Okay. Cool.
Yes. Yeah. That sounds good. Yeah. All right. Okay. 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 Yeah. So local states. So this is always pretty interesting as well. And so some ideas here about how we're modeling a local state and defining a local state. So there's kind of these 4 ideas about things that are publicly available, whether the local state is actually part of the system itself, inside the system, whether the information is privately held, and whether it's outside. And they are not all the same. Like, so like the we first might think of, okay, well, if it's publicly available information, it's part of the system itself. And if it's private, it's outside. And that isn't actually always the case. So some examples might be that, say like you were just, I might use Uniswap again, or any other, say like where you're going to transfer. So like you may have, say like if you're designing the Uniswap system, say a liquidity pool in that case, then if someone just came in and swapped, for instance, they aren't really part of the inside part of the system. Like they've used it and they've left, right? But they have made a lot of public, so like, they would really kind of be outside of the system, but they would have publicly available information that they've just revealed, right? So they've given their price preferences as part of their actions, right? And the other thing that outside of this, so the other thing to consider, say like in a Uniswap example, might be that like, well, you don't need to model all of the Ethereum tokens and all of the Ethereum addresses, right? Like that's not part of the inside world of the system. But even though that's outside world, even though that's outside world information, that's publicly available information. So it's not, it's not, it's not, if it's outside, it's private, and if it's inside, it's public. That isn't always the case, right? That the entire set of Ethereum addresses and balances is publicly available information, even though you may only be using, like, say, like a subset of that in your say like inside local state. The difference versus like, say, like your inside world or your interior local agents would, say in Hydra and also or Uniswap, would be like, say, liquidity providers. So like they actually are agents that are inside the system they're the set of agents that are inside the system at any given time. So again, like they have both their inside, but they also have publicly available information about what their stake in the liquidity pool is, but you still don't necessarily know what they like when they might pull out and remove liquidity. Yeah, question.
Paulina, go.
Yeah. Can we compare inside world and outside world with like exogenous variables and endogenous variables, or is this not the right way of looking at it?
It depends. So no, I wouldn't say it's not the right way. Like there are exogenous variables like that we'll talk about, but like there may be that where we may be modeling actors, and so we might be like trying to specify, okay, what is what might drive this action. And so like just having a better idea about like, and again trying to specify really like what makes up, what are the variables and what are the really the dimensions or the actions that are both available but are actually being taken. And so yeah, of course that's absolutely, like any of these privately held beliefs are going to be a complex combination of exogenous processes and variables versus what's actually happening inside the model. Like that, yeah, that's absolutely true. And so like, yeah, so even here, like, we might have some, we're talking about like private beliefs here, and we might talk about a future state of the system, but that's absolutely like, yeah, absolutely can be modeled as a combination of what's happening, say, to, in a system with, say, currency fluctuation happening outside. Absolutely.
Thank you.
And so then we can have sets of exogenous states. So ideally, in some cases that you're able to actually identify these from your system map and try to identify what the external processes are, versus, but obviously like there's a lot that, that could be up for debate about what is absolutely, the external exogenous process that's happening. Also, like, in terms of like, say, like modeling, say, like unknown changes, or like, then you start to model essentially distributions or stochastic vectors. And that's, also part of why we have cadCAD, and is to allow us to model those and do Monte Carlo simulations to be able to test some of those assumptions about what is happening on the outside world. And so, yeah, so I'm like, kind of like, again, idea would be that, let's say, like, you have a token that's inside, say, some system, but it's, but you're making preferences about what Ethereum might do. Okay, so that's roughly like, that's kind of the set of the states. And this maps, again, that combination of things. I'm just gonna pause for a sec. Let me see if I can, no, you know what I'll do. And I know John Sheed was kind of starting to, go under the hood here a little bit, but, again, like roughly these things are mapped to, there's two files in the simulation, so that we have the state variables and the params. And so, this is really like where essentially all those ideas are at least defined. And we often, the other thing to think about, like when we're doing this, like I mentioned, like thinking about domains and dimensionality. So like really what we're doing is we're defining the data structure. And so that's, like between the state variables.py, we're really kind of saying, okay, here are the state variables. We'll look at these again, but I just want to like point that out again, or kind of before we get into it, but, this is where they are. And as well as, this is also where the local agents are. And then here are some assumed, like really the beginnings of, say, a stochastic vector, very, simplistic version of that, but, so some exogenous process here really was like what we're really talking about with the state variables. And then the parameters are here at this level. So down here, and some of these are for testing, some of these are like actually part of the system itself, like so kind of a stateful parameter versus parameters that we might use to test outside, like to set up our Monte Carlo runs or other tests.
And Barlin, there's one question in the chat. Does the information provided through oracles come under exogenous states variables?
So that really, yes, it does. And then the question would next be, though, what are you doing with that? Like if you, because there's plenty of systems where they're actually using oracles to say, like, set a price on the system itself, right? So kind of the dependency on that, can be very high or very low, right? Like you could use oracles to make assumptions about what agents might do versus using an oracle to, make, almost centralized control decisions. So it really depends.
Mm-hmm. Okay.
Right. Yeah. Good. Okay. Yeah. So all that state and parameter stuff is really kind of focused on that X as an element of X kind of thing. Now we'll go into, this idea about mechanism mapping. By really just trying to identify what are the necessary mechanisms. And this is where, like, if you've drawn your state of the system, now this is kind of saying, okay, what are the things inside that system do I need to have happen? That's really all we're talking about right here. So we're saying, okay, what are the things that have to happen? And then you're really kind of just trying to, at this stage, really try to say, okay, like what is the input and what is the output, without actually necessarily developing the algorithms or doing the functions themselves. There are certainly times, and you know, like everyone, like if there's a natural tendency to say, oh, well, I'm going to design this, you know, best function ever right here, right now. That may be the case that is able, like you can do that, but also, like, is that all the best function ever in the context of all the other mechanisms that are available? And, you know, in the blockchain case, where it's deployed, where anybody can use it, and that sort of thing. So so really just kind of, you may take a first pass at that, but you know, each one of those is probably going to need you know, quite a bit. So, you know, really just kind of those building from those ideas. Yeah, so that's really our mechanism mapping. We'll look at that, like what that looks like for Hydra next. And then yeah, so then we have like kind of the action space, the admissible action space here for the U. So we essentially, in some cases, like in this case, there may be roughly like a one-to-one wording of, you know, the action is roughly the mechanism. In this case, that isn't the case. Like if we have, say, a system that had a set of control processes, or, you know, like control policies, et cetera, that are actually part of the mechanisms, where like they say like a user wasn't necessarily making those actions. But there's a, like I said, there may be a one-to-one wording, but there's not, it's not one-to-one in the sense that a user cannot say directly that, okay, I want the new value of the state of the system to be this, right? Because they're acting within this other set of other transactions maybe happening or are happening at the same time. So they're not able to say what the output of the state of the system is. They can only impose what their action is. And so, you know, we might look at, you know, like this like kind of role taxonomy, like who the users are, what they're expected to do, and like whether there's permissions. So like, you know, you could have controls here like that, like there could be, you know, a centralized control actor, but again, like they're not, it's an action. Okay. And then, so like that would be roughly like, once you have that, then you've essentially done like that concept mass spec, before we get into like actually designing the set of algorithms that actually make up each one of the mechanisms that we've defined that needs to happen. So like, this is where, like, again, you would now, like, once you've done that whole pass through of states and mechanisms and actions, now you would start to do this like almost in another like interior pass into each function, each mechanism, and start to like really, you know, like do the math. So it's kind of hard to necessarily show it abstractly. Okay, what does doing the math look like? Well, it's you know, plotting, it's writing down, it's testing different functional forms, etc. But you're still managing to pick your head up to see, okay, does everything that I've already said still hold true? Do I need anything else? Do I need another parameter? And it's not always, and it's not always the case that it's more either. It's not always more. There may be things where it thought, hey, I need this state or I need this parameter, and it turns out I don't. Sorry, I can't turn this off. So, all right. And then I think this is the last one. So, and then we have KPIs again, like, sorry. Okay. So yeah, again, like this idea that this may be kind of like more like a little bit downstream effects of the system. Again, that doesn't necessarily mean, like, say in a model, these might actually come in because they might be part of, say, like what a user might have been looking for, et cetera. So, so yeah, we kind of talked about that a bit. So hopefully that it gets fuzzy in the model. It gets fuzzy, you know, like, again, because if we're trying to use this when we're modeling behavioral actions, like then we are going to put them into a model. But if we're really saying like, okay, here's the system, here's all this, everything that happened, okay, here, and then analyze what happened with a KPI, then we're pretty confident about that distinction. Okay, so I will pause. Should I pause there for any questions? So the next thing that we'll do is we'll go into specifically what this looks like in the Hydra system. So like that was kind of the abstract version, and then we'll.
Any questions so far on what we've heard so far? All good? Yeah. All right. Then
so
let's go on.
Perfect. Okay, so we saw this before. So yeah, so our global state. Okay, so what does this look like in the Hydra system? Oops, tokens. Yeah, here we go. So kind of like our token states here that we have for the Hydra system. So what we have is that because we have this, I'll start with kind of Q, and I know Jamshid kind of focused on Q last week as well. So like Q are the Hydra tokens that are in any existing OMNIPool, right? And so then what we also have then is these, we have L as like the set of all available risk assets. So they're not necessarily in the pool at any given time, but it's really like, so you could think of this like almost as external, right? Like if they're not in the system itself. But, you know, again, like really, you can kind of build awareness that these are all potential, any of the all possible risk assets, because they have potential to be introduced into an OMNIPool. Like, you know, so you want to build that notion of where they are and how they would fit inside the system. So really like kind of these, you know, first three are building that idea about that. Then inside any given,
but risk assets has been specified in the last lecture. Risk assets.
Mm-hmm.
Okay, good.
Oh, are you asking, or are you?
Yeah, I wonder if everyone is 100% safe in what is the definition of a risk asset.
Yeah. Okay. Yeah. So it's I'm not exactly sure why we have just used that term almost throughout this entire design, but really that is any other asset that is not not Hydra.
I see.
So maybe a bit of a misnomer, right? Because we're not actually saying like, you know, like, yeah, because it could be a stable coin, right? And yeah, we've kind of just said that it wasn't Hydra. It's like anything else. Yeah. Okay, thanks. No problem. Yeah, we might want to revisit that name. And we've certainly, you know, a pretty important quality here would be that, yeah, like that there would be stable coins that would be, you know, in an OMNIPool, or even baskets of them. But yeah, very important. Thank you. And then so then shares. So again, like, yeah, these would be liquidity shares of the OMNIPool that are in existence. So, you know, like whether that is actually specifically tokenized or you know, or an accounting, and in this case, like we do consider them as an accounting value, but you know, in other cases, those might be tokenized, right? You could take your liquidity token and go and you know, do a secondary trade or, you know, leverage with that. So that's kind of the global state of the Hydra OMNIPool.
Well, why is there not reserved token assets like HDX? Are they all in the pool? Would you not want? I mean, I don't know all about Hydra yet, but I thought if it's the token, native token is HDX, which would be in the pool. But if you have reserve risk assets, why would you not want to have also HDX reserve assets?
So the HDX reserve assets that are in the pool are what we call Q.
Yes.
Are
they a reserve?
What's that?
Are they a reserve, like a surplus buffer?
They are the reserve. Like they are like they're the Hydra side of the reserve of the pool.
Oh, okay, but okay, maybe it's just the definitions I need to read more about.
So yeah, but you're actually bringing up something that we'll talk about. Like, and in the model, you'll see that we also have H as being the quantity of Hydra in total. And so to clarify, so for right now, because we only have this liquidity subsystem that we're modeling, and because we don't have any other subsystems about Hydra modeled, Q and H are 1-to-1. But where we're actually like, so really like H is actually an exogenous variable in this case, because like there's minting and burning about Q inside this pool that affects the quantity of H in total. But we also don't have inside this pool necessarily everything that could happen to H. There are other things, other subsystems that can happen that aren't modeled. So that's why we have H as also a variable in this pool, in this model. But for right now, that's purely a 1-to-1 mapping between Q and H. I hope that might help. Okay, so then
Great, Balin, and two more questions actually.
Okay.
Amanjo asks, and this refers to the HDX tokens. Again, HDX tokens get minted and burned accordingly, so there aren't any reserve tokens outside the pool known to the system. Correct me if I'm wrong. Maybe here we should differentiate between the real HDX ecosystem as it is and your simulation and the model. So in the model, HDX Q and the total supply is 1-to-1, right?
Yeah.
But in reality, it isn't.
Right.
Amanjo, does that help? I hope. Otherwise, please let us know in the chat. And Paulina.
Yes, can you just explain the last two variables a little bit more before we go on?
Yeah. So yes, and a point I'll make is with about the H and the Q is that there are other systems to be designed that we weren't necessarily constraining that 1-to-1. That leaving it open that there could be changes to the amount of H that is in existence versus what's inside this set of OMNIPools. Yeah, so then so the R, that's essentially like I guess you've seen some, like probably back in the very first lecture, about what the OMNIPool was, but this is, so we have some probably better pictures. I don't have really any good pictures here, but the R is like, well, we have the Q, like the 1/2 of the OMNIPool, and then the R is the set of all other assets that are making up that pool. So, in the language, in the symbols we're using, we're calling those like RI and RJ and RK, but they're different tokens that would be making up this OMNIPool.
The quantity. So this
Yes.
is about the quantity. Yes. Okay.
Yes. Yeah. And we vectorize it here, like, and when we look at the model, like kind of like each, what I did was essentially made like this asset class, and then like each one of those has like has its own amount of quantity, and then they're vectorized so that like you also have the amount of shares for that. So like, so you have an RI, then you have an associated SI. So they're vectorized that way. And then in some things like in other, say like balancer, you might have weights, like, you know, like those would also be like analogous of that. You would have this, you know, these assets that are making up the balancer pool, and they would also each have their associated weights. And then like also within that class, like you could still even build in, say like a stateful metric about the price of that asset, you know, vectorized in this pool for each one of those assets.
Okay.
Alan, maybe let me very briefly share my screen, and I will show.
Sure. Yeah.
Quick look at the clock. We have 30 minutes left.
So this would be basically the Hydra OMNIPool and trade action visualized. So on the left-hand side, you see the three assets, which are A1, A2, and A3. And in the MET spec, they would be denoted as risk assets. So this is, for example, Ethereum, Bitcoin, and DOT you can put into the pool. On the right-hand side of the pool, you would have HDX. So this is what we denote as Q. And a condition of the Hydra OMNIPool is that the left-hand side of the pool in value has to add up to the right-hand side in value. So there has to be a 50-50 distribution between what you see on the left-hand side and what you see on the right-hand side. So this is where you say that the HDX or the Q, as in the net spec, would be minted accordingly to always match the value on the left-hand side. And you see for each risk asset that you provide to the pool, you would see the shares on the right-hand side. So this would be the share tokens. So each asset has its corresponding share, which means that as Balin said, it corresponds to the proportion of this asset in the pool. And here in this visual, you would also see a trade action. So you see that the agent in blue provides asset 2, and he would retrieve asset 3 from the pool. So this is what's going on. And I think, I hope this helps understanding how this connects to the MET spec and how the particular structure of the Hydra OMNIPool has the consequences of having to vectorize the risk assets and to vectorize the shares. Because remember, if you compare this concept to Uniswap, you could, for example, forget A1 and A3. So you would only have A2 on the left-hand side, one risk asset on the left-hand side, and an additional risk asset on the right-hand side. So both assets would be provided by the liquidity provider. And in this case, only one asset has to be provided by the liquidity provider, in the case A2, and the right-hand side of the pool would be minted by the protocol. So this is the big difference between the OMNIPool and then the comparable AMM, which would be Uniswap. So I hope this helps.
Cool, thanks.
All right. Okay. Yeah. So yeah, we'll try to move. Yeah. So next up in the Hydra OMNIPool mass spec, that we have the parameters. I think we'll see what these look like in the mechanisms themselves. I think the only important thing to say here is that, you know, again, like that you wouldn't necessarily know this from if you were going top down saying, okay, states to parameters to designing the mechanisms. Like, again, like this kind of came out of the development of the mechanisms themselves. And so, you know, like the satisfying those requirements is where the parameters came from. And yeah, so then metrics. So we have some metrics that are actually, you know, you'll see are modeled the state variables within in the model itself, as well as I mentioned, like the two price ones are actually within the asset class itself. And I will jump over to that if you want to see that here. So that's easier to, I know it'd be a little faster to jump into VS Code, but I think So we can see those. We see the Y being the metric that was specified there, but then also if we look at the asset class here, then we also see like that we have price as, you know, as a vector across those across the risk assets. So and reserve and shares and the coefficient. Next up, so the local state. Yeah, so like we have this agent stat and agent number, and they can have reserve assets and base assets and risk asset shares. So we should point out, I guess there's quite a bit here that I can kind of, oops, you probably didn't even see that. I was jumping over to VS Code to see it, but you probably couldn't see that. So yeah, so like what we have is we have a agent class. No, that's yeah. So what I did was this, and so with agent modeling, it's, you know, it can be a Pandora's box, and so, you know, try to be careful about like when to open it up and, you know, when the right time is to do that, right? So like we were really in the verification and validation stage, and you know, you can spend a lot of time you know, designing a local state, designing preferences, etc. But just kind of like a little bit about the data structure here, that this is essentially what I did. This is essentially, it's a data frame where I kind of made 8 agents and essentially gave them not only that set of that we just saw. Well, let's jump to it here. That we saw the RI and the base asset and the shares, but also just kind of like also in verification. Part of what I was doing was to make sure that like essentially having accounting for if they brought in assets as liquidity, like technically those are gone, right? They've given those to the pool, and what they get back out would be shares, right? Like that's you know how this liquidity happens. But so like I was really just doing this as verification to see, okay, you know, making sure that all the accounting was correct, but then also being able to use this as essentially as a measure of what they put in, and then being able to compare that to what they got out when they decided to say remove their liquidity, and you know what happened there. So you can see, like, so that's why I'm kind of saying that that's virtual. And then so yeah, so essentially we have like that they would be holding, they would have some assets, whether they were, so this doesn't matter whether they were going to use those assets to trade or whether they're going to use those assets to provide liquidity. They would have essentially like this outside amount of, you know, Ethereum and Bitcoin and you know, anything else, that would be an outside version. And so like, and then they could have the RJ being outside as well. But then, you know, like once they kind of like are inside the system, well, then they've got each like, or well, yeah, actually, yeah, I take this back. Like, and this is where I was saying, like, this is like their H holdings that aren't actually necessarily tied up in the OMNIPool, right? Because again, like we're saying here that there's like the amount of Q is in the pool itself, but like there's other things that can happen with H outside. And so they could have H holdings outside. And then, yeah, and then once they're in, so that's why like it would be again like a virtual. If they added it in to the OMNIPool, it would be a QI virtual. But again, they would have then shares there. And then yeah, so like yeah, we don't have, yeah, so we have we don't have exogenous processes defined in this model as a price coming in, but what we do have for exogenous processes are essentially the availability to essentially have price be used to say make those actions, but like so just be like a possible entry point of where we can do it. Okay, and then we're going to, so like again, like so yeah, jumping back to like the math spec and like what are the mechanisms that are what you would map, and so again, like, you know, just at this stage, you would be just really looking to say, okay, like what is the function I need, really identifying what are the set of mechanisms I need, and what are the like, you know, essentially what are the inputs necessary to make this function occur, right? So like it might be as simple as writing this down. Maybe you don't know every one of these things at the first time you sat down to do it, but you had like some idea about, you know, if I'm going to add liquidity, okay, well, I know I need, you know, I know I have some, you know, some risk assets coming in. Okay, like I know I'm going to have shares coming out, like those sorts of first passes about input and output, and like, okay, and what else is affected would be affected before we actually sit down and do that. So I think that's basically, you know, like how you might do, you know, this mapping. Again, this is kind of complete, but, you know, trying to keep in mind that this may have like been a process that was gone over a few times. And you may like be able to take something, say, for granted, like maybe not in this case, but like, you know, there be times where you say, okay, like I know I'm going to use some existing mechanism that, you know, is already in existence and it already works, and like, you know, anywhere you can kind of like start to build from and be like confident about it, I think also helps for you to do everything else. Oops. Okay. And then, so the actions in this case, you know, like they're kind of in some ideas, they're one-to-one with the mechanisms, but, you know, like in this case, they are, again, it wouldn't be the case if there are a lot of control or, you know, like centralized or even decentralized governance occurring. And then the other important thing here, like these aren't the actions, these are still the mechanisms, but really it'd be, okay, like what is actually coming in for the action? Well, in this case, like for like adding liquidity, like you would just be bringing in like, you know, a risk asset. If you're removing liquidity, like the only thing that coming in would be like the shares, right, to be able to remove, etc. So we have, I'll go through these a little bit in more detail on the next series, but yeah, so like kind of like, you know, this is what might be like your checks about the available action space for adding or removing liquidity. You know, that like you have, if you're bringing in this RJ, like are you able to do that? Like, are there the shares? Are there enough shares to essentially be removed, or essentially can you add that amount? You're swapping, again, from the action side of things, like you really are just checking to see like both whether you have the required holdings that you're actually bringing in, and then are you able to essentially remove the other side? Is that in existence enough for you to remove that many tokens? So that's like essentially like, and these are some ideas about like I'll go through each of these. I'm going pretty quick now, but through your admissible action space, you'll see in reality, like in a lot of these actually deployed systems, like these checks actually happen like in multiple layers. So like, you know, we don't necessarily do that perfect mapping, say in cadCAD about these checks, and we don't even necessarily because we haven't focused on building out, say, like the action space itself too much. We didn't want to impose like all the restrictions on the action space before it was actually necessary to impose that restriction. So, you know, like it wasn't really germane for us right now to see, okay, like, you know, doing the simple conditional logic about, oh, can I remove this amount or not is so simple that we didn't want to like have essentially a simulation break because like we didn't give the agent enough tokens. Like that's of course a real thing that we would absolutely do at a later stage, but because we're really focused on the mechanism itself, like those aren't always necessary to do right away. So again, like, you know, again, just through swapping, like really starting to lay out what the actions are. And yeah, so if you're swapping again, like just needing the right amount of tokens. I know this is going to be too quick for you guys to go through now. So you'll just get the slides and we can talk about it quite a bit more. And then adding a new asset type. Yeah, so that's like where you would actually bring a new asset that isn't actually in the OMNIPool itself. So that actually requires its own mechanism in order to do that. And that, you know, would require some more work, like about establishing the initial price. So there are some like, there's still some boxes here to kind of go over, but still the idea about that action is still like available, that needs to happen as in the pool that you would be adding a new token to the pool. Okay, so yeah, so let's do this. So I'll give you essentially do a very fast pass through the actual mechanisms themselves. I don't know, obviously you're going to have the slides, but I can kind of show you like where they are both. I mean, you'll get them here, the math part, and then also like what it looks like in the code itself. So like, and I know you saw some of this last week as well, right? Like that here's the mechanism for adding and removing liquidity. And so really like, you know, this is really, you know, we think of like kind of the set of state variables that are updated, you know, providing that state transition, like, okay, this is what happens. Again, I'm presenting it as it's done versus like, okay, like, you know, how do you do the math, right? But I just want to point out, like, you know, and I know you saw this a little bit the other day, but if we go, yeah, to the partial state update block, and we see, okay, like if we pick any one of these, of course, you know, yeah, you are, okay. And we see here, like, okay, so for this one specifically, we were looking at if we look at add liquidity, right? Like we see, okay, here's what's the resolution of adding liquidity. You know, it's here. It's a function of all the things that we said, all that were in that mechanism here. So we see all those variables here, and then for Q, like this was the computation to get this state update for that one variable. And yeah, we would see in the others that you know, for each one of the other, like this is for probably for the yeah, so, and yeah, if you notice, like, so the pool, like that's that vector of risk assets. So what we call pool is that. So you can see that like this is the R and the S and C for that specific risk asset. And then we're saying like this is how we're updating both the actually, yeah, so the S and the C for that risk asset. So we're seeing that here. S and the C. Oh yeah, and the R is the R is updated in this method as well. If you want to see that, that just threw me off for a second, but yeah. So okay, we're adding we're changing the R and the S and the C here. So this method is really just doing the accounting, but this is doing the computation of what the values are. So obviously the R was just being come in, like, you know, that's the amount that's being added. So no computation needed there. So hopefully you're getting a flavor for like how this, I'll kind of go through these, and hopefully you're getting a flavor for like both how they look and how they're modeled. If you're swapping really like this risk assets, then it's really like this formula here is doing all the work for you. And so that would also be in the pool because it's purely on risk assets. This R to R here, and let's say, here's another one.
Matthew, can I ask, is this code also available for us, or is this the full
Yeah.
code?
This is the code that's on the repo.
So
Okay.
the GitHub link dropped to the chat just recently, the HydraDX repository on GitHub.
Yeah, that's the Galactic Council link, yeah?
Yep.
Okay.
Well, then we
I
have 10, oh, sorry, yeah.
No,
yeah,
it's
go ahead.
only, so maybe I just need to surf it a bit more. I just didn't think I could see all the, but maybe it's just me.
Yeah, let me know if you have problems with accessing it. No problem. I think it's in the model folder, right? Well, and we are now in the
Yeah.
model folder. Mhm.
Yeah, model
Okay. Parts.
parts. Yeah.
Okay, thank you.
Yep, you're welcome. Yeah, so
I'm seeing so many slides, Barlin. Still, we have 7 minutes. Is
yeah.
it okay?
Yeah, I'll yeah, like I won't go, like it would be the same theme. So like I'm saying,
Okay.
okay, you have everything here, both written as math and, you know, just as long as everyone sees kind of the mapping to the code, then, you know, then we're okay. Time-wise. So, you know, if anyone has anything that they want to see, I will know, like we have the math written here for the add new asset type, but I don't believe we had like we had an earlier version of how you would add a new asset. And I believe that's still, I believe that may still be in the, don't know if there's the, yeah, so there's an earlier version of this, like, so that's not going to be there for adding a brand new asset. So that'd be my note. We're going to spend, like I said, we'll spend a lot more time, we'll devote all the time next week to really saying, okay, like here's the mass spec, like we've already said, here's the mass spec, and really looking more to how cadCAD works and where everything is. And hopefully you're ideally seeing this here. The only other things I'll say, like, so you won't see, like, so again, like to drive on the earlier discussion about KPIs, like, so we have slippage and impermanent loss as, you know, identified requirements about KPIs, but you won't see slippage and impermanent loss in the model. We have in our analysis, and what you'll see kind of in the lecture 2 weeks from now is really focused on those two KPIs as analysis after the simulation to determine as part of that parameter selection.
Can I just ask here? So slippage and impermanent loss are not dynamic parameters that are influencing agent decisions in the model.
Oh, no, I didn't know. They, in the model, as written right now, because we were designing the mechanism versus doing really agent-based modeling. Yeah, so like, and that's yeah. So like, good to ask the question because it's going to drive home that point, right? Like that they are not part of the system itself, right? Absolutely, yes. That if you're going to design an agent that is going to take these into effect, which they obviously would, then yes, you would bring them into the model. but they aren't actually part of the system. But yes, they would be part of a model where if you were interested in that, which makes sense, like, yes, you would bring that in and you would bring that calculation into the model itself. Good. Yeah, so so we're hoping to build from where you guys have been going, and from the system map to starting to think about as a GDS, like getting an idea of your state, and really kind of like now taking the next couple steps in how could you go from the system map and the GDS to building a math spec. And so you would start to look at, say, this kind of first bullet point would be, again, like you've already done the state, like kind of the state mapping from GDS. So this would really be like your concept math spec getting to this point. And then, I mean, obviously, like depending on the complexity, like this may not be necessarily achievable, like actually defining a set of algorithms that can be a lot of work, but like at least like taking like a simplified version, or at least like say like taking one mechanism and being able to take what you've determined and turn that into an algorithm or a set of algorithms would be the goal. So hopefully what we've seen is essentially like how to build and how to map this out, while also getting like what probably can get more about what the Hydra math spec is doing, but you'll have it here, and you also have it accessible to you in the model, and that'll be the focus of next week.
Cool, thank you, Balin. On the homework assignment, I think we have a couple of people that already are continuously working on their system of choice. This is not HydraDX, but another project, and this is great. So continue to work on this system according to the step-by-step process and the homework assignment now until next week. However, just in case there are people now in the call and in the group who haven't worked on an own system, I feel since we later will, I mean, the question from Hydra is, okay, come up with dynamic fees. Alternatively, people can make themselves familiar with the model and with the specification, and also dig through it, since I guess there will be some more open questions as we've seen it today on the very particular aspects of HydraDX. Will this be an alternative, Balin, just in case people don't have an own system?
Yeah, I think so.
And again, next Tuesday, time for your questions. So it can be about the Hydra case, it can be about your homework assignment, and of course the mechanisms and specification you derived. Amandio, you have a question.
Yes, it's from the previous slides, some earlier slides. What does the notation under the domain section mean? So I just wanted to ask that. Some previous slides.
Yeah. Here?
Yes, these notations under the domain section.
Yeah, so the R++ we use for real but always positive, and not including 0. Let's see what else. And the so the price again, same thing, but because it's across, it's n by n, because you have a price matrix, like for all the assets that you have like essentially all the price pairs. So that's why that is n by n.
Okay. Yeah, thank you.
Yeah.
Okay, any other questions on this lecture, homework assignments?
Henrik, one question, I guess, is, I mean, what you just mentioned with the homework versus the HydraDX project. I mean, I guess I've reflected on my project, and I think it's terribly complicated to get through all steps of all dimensions, endogenous or exogenous or whatever. So I would actually just say, okay, for the heck of thinking it through, it's a good exercise, but for the next weeks, many weeks, I guess, wouldn't it make sense to link up on the Hydra questions? I mean, I hear you suggesting if you don't know what else to do, then focus on Hydra, but isn't that shouldn't it be the opposite? Maybe we should focus on Hydra mainly. I guess that would be easier for learning, isn't it?
Yes-ish, but of course, I guess Balin and Chris had a particular idea behind these homework assignments, and that I might not know and see.
Oh, yeah. So I mean, I was going with whatever you've been working on as your example. You've already kind of built a pretty good understanding of those first two building blocks, the system map and your GDS. So this would be kind of like the next one. And yeah, like, I mean, I don't really expect, if you can design a system that like often takes us like months to do in the next 4 days, like, you know.
No, that's what I mean. That's a terrible task for 4 days.
No, I don't actually expect that. More like about going through the process, like, you know, sitting down to try to think about that, making that one iteration through to get the feeling for, okay, like here I identified some state variables, I jumped to actions, I identified those, I have some idea about the mechanisms and like what, and then maybe that dawns on me that here's a parameter I might need, or here's like, you know, yeah. So really just that a first pass would be, you know.
Okay.
Yeah.
So
Just one thing. Sorry, but I still don't understand the domain section. If you just could go through it once again. Is it a mathematical concept that maybe I'm not familiar with? So what do the notation mean? Is it something very important to the system itself?
No, I wouldn't say if you're having trouble with it, it wouldn't. It may be that you actually, like, if you're, say, like coding, like you may have already done this, and it's more about like, and like it's really just it could be, you could think of it as like it's a byproduct of you went and coded and said here it is. But if we're really like starting from the beginning of defining, you know, what these variables are, or like what dimension they are, like then that's really just trying to put that down. It's important if, you know, if you're running into essentially implementation details of whether, like, you know, like in blockchain, like whether if everything's a real number, like that can be a problem versus it's a lot easier with integers, etc. Yeah, so like, you know, we're just saying like all positive real numbers is really like what the R pluses are, and the prices are positive real numbers across an n by n matrix of whatever the number of risk assets that are available are. And then and then like, if I believe this is actually a holdover, but like for the weights, if there were, it would be like in the domain of 0 to 1, but again, it would be vectorized, so you would have like n amount of weights for each risk asset that you have, but they're normalized, so they're staying between 0 and 1.
Oh yeah, understood. Thank you.
Okay, so back to this case thing. I think your proposal, Balin and Chris, was just take an example that you feel familiar with, take a simple example and try to come up with mechanisms with the specification as good as you can. It's no need to have the final set and the final model, of course. But if you feel like, okay, I need to dig through HydraDX, maybe sometimes I realized in other courses or research groups, at some point you're so familiar with the concept of AMMs, with the concept of Hydra, that you just feel, okay, this is all clear. But guys, if you feel, I need to understand this general concept of Hydra, and then feel free to dig through it starting now and asking questions for clarification. Like for me, risk asset, it's not a familiar term in the AMM space, but it's specific to this model. And in order to work with this model, you have to understand, and this is what you can do in parallel. And take the hack and share sessions as an opportunity for clarifications.
Yeah, I think the important thing that we've been kind of going through with the assignments are really like going through that going through the process is what we're kind of hoping to get at, as opposed to we're not expecting finished designs. Again, it's just more like, oh, here's how this works, in terms of like how you realize your own iteration, how you realize your own places to go back and erase and make those changes.
Awesome.
Yeah.
All right, then I'd close the session for today. Thanks a lot, Barlin, Chris, anyone who asked questions, and everyone else. And see you all next Tuesday at 3. I'll drop the link in the chat, in the Discord again. And again, wherever you are struggling, whatever questions you might have, either drop it to the Discord or show up on Tuesday, and happy to discuss. Great. Thanks a lot. See you next week.
Bye-bye.
Bye.
Thank you. Good night, everyone.